Hello, everybody. This is the Evernym sprint demo for it's the end of August 29th, and we're excited to show what we've done over the last 2 weeks. The main thing we've done on the Indy node side is focused on getting PBFT view change done. We're expect to complete that in September. There's some risk. We've been fixing a bug on Sovrin BuilderNet that we discovered. BuilderNet served its purpose, and we found a problem. Well, Lynn found the problem and reported to us. So that put things a bit behind schedule, but we still think it fits in September. So we're working on that. You can see a number of bugs fixed on the PBFT view change side. On the Indy SDK side, we completed, we have CentOS builds that work. That'll be nice. We got some additional documentation out on the Indy SDK that should be important for the people looking at how to evolve Indy SDK into the Aries libraries. We also fixed a number of bugs, and we've got the release out. In the next release, it missed this release, we finally have support for fully qualified DIDs in the SDK, as well as so when somebody gives a fully qualified DID, it'll take the fully qualified piece out and talk to the Indy node. On the ledger, it won't be fully qualified. And we have some APIs nearly ready to allow people to migrate the existing DIDs in their wallet. So that'll be useful for people. And we've been doing some studying of the Aries side of things to get a sense of how best we can contribute. Over the next couple of weeks, we're going to be focused on guiding that Aries architecture to something that meets our needs, as well as works well with the rest of the community, and figuring out the right place for us to contribute going forward. We do want to get the Mac builds working fairly soon, but most of the rest of forward progress is kind of stalled, completely stalled, as we figure out how we want to structure things in Aries. So we feel like we've solved the most important bugs, and at this point it's figuring out what the future should look like. So that's our main focus. With that introduction, Sergey is going to take us through his new documentation. That if you are interested in the Aries project and how Indy should look as it moves into an Aries world, Indy node stays unchanged, but the SDK becomes an Indy resolver, the wallet becomes an Aries wallet, the crypto becomes Aries crypto, then you should look at this documentation so you can be well informed in why things are the way they are and how best to meet those same goals in Aries while working with the new stakeholders that are in the Aries project. So with that, I'll stop sharing my screen and let you share your screen, Sergey.
Thank you. So I'm going to tell about our new documentation. It mostly was done a sprint before, but in current sprint we add some more files and perform some cleanups. And now I'm going to present our results. So you can find new documentation inside docs architecture folder of Indy SDK repo. You can see a list of files here, and I would like to make an overview of them. There's one more documentation, so the majority of them are inside docs architecture, and one more document inside how-to. And here is how to add new API call. In this document, you can find step-by-step sequence how to add new API, which layers of Limbidi should be affected, etc. So now I'm going to jump to my IDE and show some diagrams and files. So inside architecture folder, you can find the diagram about Indy SDK components. On this diagram, you can see dependency between libindy, various wrappers, libvcx, pluggable libraries like for payment on wallet. it's called Indy SDK components. Also, you can find links to language libraries, bindings. Here you can see also links to samples and source code base as well. And there's an interesting document around libindy. This document describes libindy layers, libindy architecture. And the main goal is describe details and try to share our motivation and goals. So this document is like an extension for how to add new API call. But in this document, you can find more details, more reasoning, and more suggestions. So in general, libindy has 3 layers. The first one is the API, the second is commands executor layer, and the latest one is the service. The second section of this document is purposes of these layers. So you can find which layers are devoted to which steps, and goals. For example, API layer is a really small layer. It just performs some conversion from C to Rust and just prepare appropriate Rust comments to the comment layers. Comment layers is some kind of aggregator. He can split the complex command requested by user to atomic operation and propagate these atomic operations to the services. And services layers are well isolated against each other, so there's no interaction between one service and another service. So it improve code readability, make better developer experience in our libindy, and so on. And at the bottom of this document, you can find more details about layers interaction, how API layers, API models relate to each other, how API communicate with comment executor, how services and comment executor are combined together, and so on. So it's a good document to understand how libindy code base is organized. And also in architecture folder, we can find more diagrams. So you can find, I would like to focus on threading model. On this diagram, you can see how code is running for application. So let's take a common example, like a regular call of libindy. On this diagram, you can see by example of create and store my ID. This call is requested by client app. So it passes to a libindy API, and this libindy API runs on client thread. Then libindy API prepare, create, and store my DID command, transfer it to command thread. So this command thread is something like main thread of libindy. It executes a majority of logic in libindy. So it performs necessary operations and execute a callback provided by the user. So the user will see a result for this callback. There are some exceptions in this flow. For example, if we are talking about some very CPU heavy operation, for example, to create a new credential definition, you have to generate a lot of keys. And as these keys are RSA based for now, it took a while. So I mean, for this type of commands, we don't block common thread of libindy for a while, but instead of that, we separate an atomic CPU heavy operation and pass it to thread pool for expensive operations. And while new keys are generating, libindy are able to process our comments, for example, request to a ledger, etc. And there one more exception for calls which are almost synchronous. They can be performed just in client thread. I think that's it from my side. Any questions?
This is great documentation. Answers a lot of questions about the different layers and how the threading model works. It's going to be really useful for the people who are working on the Aries stuff, as well as for people who want to contribute to Indy in the months it will take for Aries to be ready for use. So thank you for doing that, Sergey.
Thank you.
Excellent. Nikita has been working on a number of improvements to how Git transaction works, making it more efficient and using BLS signatures. So ready, Nikita?
Yep. So I'm sharing my screen. And it works. Awesome.
Yay.
Yeah. So I've prepared a small presentation about the fixes we made and what we wanted to achieve. So we had a problem about getXM and audit proofread. So what was the problem? Before we were reading a transaction from a ledger by sequence number with just having a consensus of requests. So we needed like for eight nodes, we need around like 4 or 5 answers, and it was a burden. However, we have all abilities to make a proof from nodes. To make a proof from nodes that we really have it. So it will work like state proof. But we can't name it state proof because there is no state. There is just a ledger. So it is named audit proof. So we have all the data. We just need to provide enough evidence to prove it. So what is the Merkle tree and how to build proof on it? So let's imagine we have a ledger with 8 transactions. We need to build a Merkle tree. Merkle tree is a tree of hashes. So at first we make hashes from every element in a tree. Oops, there is a slide missing. We are making hashes from every element. So then we make hashes from element that goes next to each other. Then once again and once again. In the final, we receive a single hash. It's a root hash, and it's a hash of all Merkle tree. It will be signed by all nodes in pool, and we can believe that this hash is the hash of this is the hash. It's like an evidence that all of these transactions are really in this tree. And for the single transaction, we can make a proof. Let's imagine we want to make proof for the E6 transaction. We can calculate the hash of E6, and it will be H6. To make the next hash, we need H5. Then we calculate the H5 hash, the H56 hash, and provide H67. Then we calculate hash for H from 5 to 8 and provide hash from 1 to 4. And then we calculate the final hash. So what we need to provide to make a state proof, to make an audit proof in a Merkle tree, we need to provide these 3 hashes, H5, H67, and H134. We need to provide a root hash. We need to provide a signature of this root hash by all the nodes in the pool. We need to provide the ledger length. Otherwise, we won't be able to calculate from which side we should concatenate the hashes to make the next hash.
And just to clarify, you said H67, but you mean H78.
Yeah, H78. Yeah, thank you.
Thanks.
Let's go to the tests. what we actually we have made it on SDK, on both SDK and Node side, and we have a test that shows us that it works. What's the test? For the first test that we proved that it works in general, we are working with a pool where all nodes are working, and for the second test, we have a test that we can read from a single node that is still online. Other nodes are not online. So the first three tests are for different types of transaction and for different ordering of transactions. For NIM, for the NIM that is in the previous batch, and for IML that is in the config ledger. And the second three tests are for case when only one node is responding from the whole pool. So all tests passed and it works. And that's it for my demo.
So in practice, the point of our consensus is that you don't have to hear back from every node in the pool in order to have confidence things work. You just have to, if you have two F+1 nodes, then you know that you have a valid answer. But with the signature that comes from that you've calculated from the Merkle tree, you can hear back from a single node and know that it's definitely correct because it represents the state that everybody else shares. Is that a good summary?
Yeah, sure.
Excellent. So this will be really important for people. We've often talked about observer node support, being able to increase the performance of read operations without impacting the rest of the pool. And this isn't full observer node support, but it does make it a lot easier for people to read the pool and track what's going on. But you can't, now correct me if I say this wrong, Alex was explaining to me that you can't, with that state proof signature, you can say to somebody, yes, what I read from the ledger, you can know what I read from the ledger is correct, but you can't give it to a third party to say, yes, this is definitely correct. So it's not a full observer node ability, but it does allow you to track what's going on the ledger quickly. Is that correct? Or?
Yeah, that's correct.
Yeah. So we still have more work to be able to be full observer nodes, but somebody who wants to track what's on the ledger can do so in a very performant way without impacting the entire pool, just the one node you're pulling from. Excellent, very useful. So last is to talk about the releases this week. Vladimir, up to you.
Hello, let me share my screen. Can you see it?
Yes, looks good.
Okay, so I just want to say about coming Indy Node and Indy SDK releases. So on the Indy Node side, we have some stability fixes. For Indy 2211, we had an issue with incorrect config state because of ledger signature parameter in our rules that was added previously. And also we had an issue in the 2215 with ledger statuses that were not re-asked during our catch-up. And also we now we support get transaction and verify payment, use audit proofs reading. And there are some endorser fixes and additions. So endorser field in our transactions can contain the ID with a known role only, and this is role is endorser. And endorser must be specified within transaction if this transaction was signed with endorser. That was what's about in the Node side. On the Indy SDK side, we have new platform support. There are two new platforms, there are Ubuntu 18 support and CentOS support instead of Amazon Linux. And also there are a lot of fixes and additions on the Indy SDK side. In Indy CLI, we have we added endorser parameter into NEMA trip ledger create dev commands to set endorsers for transactions. And also we have added ledger endorse command to endorse transactions to the ledger, and it can work with a CLI context. On the libvcx side, we also supported endorser transactions, and there are a few new functions in AnonCreds API to rotate credential definition. There are they were added two new functions, issue rotate credential definition start and issue rotate credential definition apply, to generate temporary keys for existing credential definition and to apply temporary keys as the main for existing credential definition in the wallet. Also sign and verify commands with payment address were added to libvcx. In the SDK side now also supports state proof verification or audit proof verification for get transaction request, and also we have an extended config parameter in the OpenPool Ledger function to accept number read nodes value. By this value, we can set the number of nodes to send read request. So this is a short summary for.
Your mic went quiet, Vladimir. Did it get bumped?
Could you repeat your question, please?
The volume was good, and then it sounded like it suddenly got quiet. But you.
Okay. Actually,
it sounds better.
Okay. So it was a short summary about our releases, our upcoming Indy Node and Indy SDK releases.
We only lost the last bug you were talking about, so.
The last bug on the Indy SDK side, am I right?
Yeah.
So we have we support audit proof verification for get transaction requests on Indy SDK side, and also we have extended config parameter of Indy Pool Ledger that we can set the number of nodes to send read requests now.
Excellent, and we expect this to, we expect the Indy Node stuff to be released tomorrow, and the Indy SDK stuff probably on September 2nd. Is that correct?
If there will be no issues on the both side, I believe we can release both packages by tomorrow's evening if there will be no issues.
That'll be great. Our August release will be in August. Thank you for your efforts, Vladimir. Now, two questions I've received from people. First is with the release of Indy CLI that has transaction endorser support, that we released the node changes, the API changes in July. And so that is already live on Sovrin mainnet. We haven't tested the new CLI against the July release of Indy Node, but we believe it'll work. It won't have the state-proof stuff. It won't have those optimizations, but it'll be correct. It'll function, and so people can start using that immediately. They don't have to. We believe people can start using that immediately. They don't have to wait for the August release of Indy Node to make it onto Sovrin mainnet. And then the second question people should be aware about, second thing people should be aware of, is the fixes on for the consensus problems on Sovrin BuilderNet. The problem there is that we made the changes for public write access that says that when you're adding a new DID to the ledger, it needs to be signed with the signature of that DID. It's not on the ledger yet, but it still it's signed with the DID that's the signature of the DID that's going to be on the ledger. And there's a special field in auth rules that says this is, accept an off ledger signature. And if that field is not explicitly set in auth rules, if there's been changed auth rules, but that field wasn't explicitly set, then an incorrect value was getting written to the local node state, and that would cause that local node to fail. When a new node joined consensus, it'd figure out what the state is, it'd get this invalid option, and it would fail. And so we fixed it so that doesn't happen, but that invalid auth rules configuration still ends up getting written on the config ledger and in the audit ledger. And so people who try to reconstruct that history will end up with an invalid history. So if you have a temporary environment or some kind of environment that ended up with that invalid state, the release will fix it going forward, but it won't fix the auditability that historical state. You need to wipe your state or migrate to a valid state. We don't see that invalid state in any production network builder that's expected to be reset on a regular basis, so we're not worried about the history being incorrect there. It doesn't impact Sovrin mainnet or Sovrin staging net. But if you have a network with data you care about that's in this situation, you can reach out to us and we can give you pointers on how to fix that. But we're not going to go to the effort of migration script if nobody needs it. Is that a good summary of that situation, Alex?
Yes, that's a good summary.
Okay. I I'm glad I didn't. That's the next thing. We do have a few bugs we're gonna fix. On the SDK side, we're working on OS 10 support. We'll probably fix a few more bugs. And then the next round, and we're working on figuring out the Aries architecture so we understand how we want to work in the future. We know, but before the end of the year, we need to have DID doc support, peer DIDs, rich schemas, some of these things, but we need to figure out how it fits into the new Aries ecosystem before we do all that work. So that's where we're focused. With that, if you have any questions, reach out to us at chat.hyperledger.org. We hang out in Indy, and or you can reach us, in jira.hyperledger.org. We spend a lot of time there. So thank you very much, and we'll post another video in a couple weeks.